It's about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, I'm Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is this waveform display. Look at that. Yesterday we had something working. This is updating the screen in real time as I speak. So beautiful. What we have on the menu today is to continue this thing, because there are plenty of things that I want to do with this. First of which is actually something funny. Do you want to see something funny? So yesterday we wrote this. It was updating the screen just like that. So this is exactly where we left off yesterday. And I was super happy. And then I decided to do the thing that one usually does with a plugin when they're developing a plugin, which is to remove it and re-add it on the track. And then look at that. It didn't work. The joys of software development. So it didn't work. And I was like, oh my God, what is wrong? Let me go into the plugin. And maybe add, the plugin itself is not doing much. It's just calling on the library. So let's go into the library. And then I started looking at the values here. And I was like, wait a second, these values are not changing as I expected. So I guess in that occasion I had the local variables commented out as I had yesterday. And I was seeing these variables, there were all a bunch of zeros. That was weird. And I was like, okay, so let's debug something. And I put like, so check this out. This is super cool. I put like a debug statement here. And I saved and then it started working. What's that about? The debug statement is doing something? I don't know. So let's remove it from the track and re-add. And then it's not working again. What the hell? What is the debug statement doing there? Why is that helping only when I add it there, but not when I load the plugin again? Okay, so it's not doing much. Let me remove the debug and think about something else. Oh, wait a second. Now it's working again. Isn't this lovely? Well, I know what the issue is. I debugged a lot more and I found what the issue was. Usually I open Visual Studio Code before the stream, but I forgot to do it this time. Do you know what the issue is? You watching this, do you already know what the issue is? Well, I guess now you know, because the cursor is right on the problem. I am initializing the waveform display using the design system, but the design system is only available on the GFX block because it depends on X2Retina. So when you're creating waveforms, you cannot rely on the design system. But that's all right. What is space 96? You can just check that and hard code the value in, which may be a good idea anyway. So it is 768 pixels. And now it's working. I could have fixed that off screen. In fact, I fixed that, but I reverted it because I wanted to share this moment. Such a fun thing. The design system is not available here, but it was available when we were developing the plugin and saving and changing the code and saving, because the state was already set up. We already had this variable, so it was available for us on the init block. Typically, you don't have that. Cool story, bro. So what's next? Oh, there is some white space difference here. I probably don't want that. So what's next? Well, this kind of scrolling view where it scrolls from left to right and then goes back to left to right, it kind of works for some people. Some people like this. In fact, it is the default in some plugins. Let me think of one that does this. I think that the AM compressor by Melda does something like that. Yeah, over here. You can see that it does something like this. That's all right. It's not terrible, but I think I prefer this kind of view. So that's what we are after now. How do we do this kind of view? Well, the intent is that I'm going to keep this temporary buffer that I'm drawing to. I will keep updating it in exactly the same way, but I will render it, I will bleach it into the main buffer differently. And I will do that in two sections. So I will bleach, like from this point that is updating, moving across the screen, I will bleach the left part of that once and the right part of that separately. And I will do some clever tricks in terms of positioning so that hopefully it will scroll from right to left, just like in the Melda plugin. Okay, so that's the intent. Now, to actually realize this, there is a fundamental issue that we have to think about. The issue is that this line moving across, the one that I'm following with my cursor, this line is dependent on the refresh rate of the screen, because the redrawing happens when the GFX block runs, which in this case is 60 times per second, but in reality it could drop some frames here and there. And even if it is 60 times per second, there is no guarantee that these calls are spaced evenly and that I get one frame every 1/6 of a second. There is no guarantee of timing in that. So I have a fundamental problem here. The fundamental problem is I want the scrolling to be as smooth as possible. So I want the scrolling to not be based on the timing of the UI thread, how often that runs. In essence, the problem that I have here is similar to a problem we solved yesterday and in the stream before that. It's a problem of timing. So let's take a step back and look at the problem of timing that we already solved and look at how it solved it, because I think that the solution will be similar. The problem of timing had to do with how the samples that we want to draw come into the plugin on the audio thread, but the drawing happens in the UI thread and they run at the same time and they run in different schedules. The audio thread is running 48,000 times a second. The UI thread is running 60 times a second. The solution we came up for this communication to happen was we had this circular buffer in the middle. The audio thread is writing samples into the circular buffer, and the UI thread is reading samples from the circular buffer. And the write and read head, they are independent, and the read head is always catching up, following behind. It's always lagging behind by catching up to the write head. And as long as this is large enough for the write head not to wrap around and start overwriting values that the read head hasn't accessed already, as long as that's the case, that this is big enough that the concurrency happens in a manageable way, it's fine. It draws on the screen. Here is the proof. So we had a problem of a race condition where two different things are happening at the same time, the writing and the reading, and I have to coordinate between them. The solution was to introduce this abstraction, this bus in the middle that allowed them to communicate. And the write head and the read head had to be independent of one another. That was key to make this work. Typically on the circular buffer, you don't read with an independent read head, you read with an offset from the write head. So we had to implement this read head ourselves here in this part of the code, somewhere here in the middle. And this is the code that we wrote yesterday. Now we have sort of a similar problem. The problem is that there is this whole logic here in the middle that we implemented yesterday. I don't need to re-explain all that. But in effect, we have this chunk of screen, which is this off-screen buffer that we are writing to. It's essentially this view, right? It's essentially this view here, this big chunk of, I guess, screen space that we are writing to, an image that we are writing to. And there is a write head over there, and it's writing what this so-called columns, which are like one thin slice, one rectangle that makes up this figure. And then it writes that and it moves along to the next column, and it writes that and it moves along to the next column, and it writes that and it moves along to the next column. When it gets to the end, it wraps back to the beginning. So in essence, it's pretty much like a circular buffer. This image is acting like a circular buffer. And I could just be drawing based on the write head, and that would probably be good enough. I mean, it would maybe jump around depending on the timing of things. It could jump around a little, but it wouldn't be perfect. It wouldn't be ideal. I think that there is a way to make this smooth as your computer can handle. And the way to do that is to have this abstraction in the middle, to have an independent read head, so to speak. An independent read head. And what is the point of this read head? Well, this is the seam here. This is the division. This is the place where I am saying everything to the left of this is the past, and everything on the right of this is stuff that we are about to overwrite. In other words, to the left of this is the immediate past, and to the right of this is the distant past that we are about to overwrite when we wrap back around. Now, this is not exactly a read head. This is more like the split point. So I'm going to call this S for the split point. And the write head, as mentioned, has everything to do with the timing of the UI thread. So the write head is moving along based on the timing of the UI thread, probably 60 times a second, hopefully. The split point could be just literally the write head. And look at this updating across the screen. It looks very smooth, so that would be fine. And there are plugins that do this, I think, based on what they look like. I think there are plugins that do this. Let's try this, for instance. I think that maybe this one does it. It may not translate across on the stream because the stream is running at a lower sample rate. Not a sample rate, a frame rate. It's a lower frame rate. It's 25 frames per second as opposed to the screen that is running at 60. But sometimes I can sort of see it jumping around, just ever so slightly, very little jumps, but I think I see it jumping around. And the solution for that would be to have this split point, not based on the write head, but based on timing. So again, it's a similar problem to the one we had here. The concurrency of the writing on the outer thread and reading on the UI thread. And here the concurrency is between the UI thread writing on its own schedule and the passing of time in the real world. There is a concurrency between these two different schedules. That's what we are going to try to reconcile using this idea of a split point that is not based on the timing of the UI thread, it's based on the timing of the real world. We are going to look at the clock to move this split head along and then wrap it back and all of that. And oh, look who is here. Aria is here. Hello, Aria. How are you doing? It's nice to have you here. Let me pop out the chat and see what you have to say. Very Dan Worry waveform drawing going on. Like it. Awesome. Yeah, those colorful waveforms are getting back. In fact, I do have plans that are quite sophisticated when it comes to when it comes to coloring this. Right now I'm just doing black and white because I'm trying to get some other aspects like the scrolling right. But one influence on this is something like the Era 6 de-esser. Let me get the VST version of that. And then see how it colors things differently when it picks up an S. That's the kind of thing that I want to have, this kind of coloring. That would be fun. That would be interesting to implement. Right. Oh, and by the way, Aria, if you hear clicks and weird artifacts on my voice, let me know, because I am testing the new version of Black Hole, as you know. I wasn't testing it on our conversation with Kenny. I downgraded Black Hole, but now I upgraded back again. So if you hear anything weird, let me know. In any case, so this split point needs to move along based on time, based on the clock. And in JS effects, oh, I'm glad to know that it's sounding good. Thanks for letting me know. Probably they fixed the bug. The Black Hole people fixed the bug. Oh, it's not in graphics. I think it's time functions. Yeah, time precise. And this returns a time in second granularity. That's not good enough. And yeah, 1 millisecond. Generally much less than that. That's probably good enough. And it's useful for benchmarking, but I hope that it's not so slow that we cannot use it in the UI thread. Because this is the key. This is what lets us look at the watch. And interestingly, it says that it returns a system-specific timestamp in seconds, but it does take an argument. Oh, if a parameter is specified, it will be set to the timestamp. So it's a good old pass by reference kind of thing. I would just look at the return value. Okay, so first of all, let's see if this idea is even gonna fly, because I haven't really used this before. I don't know how it works, but I know it exists. So let's just experiment with this for a moment. In the UI thread here in the GFX block, I will create a debug variable that I will assign to the result of time precise. And then we'll see if performance is okay, and we'll see if the value updates in a reasonable way. So let's remove the effect, re-add it to the track. And look at the debug variable, and the debug variable is updating in a reasonable way. And the performance seems okay. The plugin is not taking too much CPU, though I do think that this is only counting the CPU used by the audio thread. But still, my computer is not reacting strangely, so the performance seems to be okay, and the precision is awesome. So I think that that will do. Great. So how is this going to work? Well, we have to make pretty much what we did for the read index over here, but we have to do it again. But the schedule of the update is based on time precise. So that's the idea. Naturally, we will need to store this split point in the data structure because it's independent of everything else. I cannot compute it based on anything else. So I'll need to store it here. So let's extend the data structure to have the split index. That will be the 10th part of the data structure that now has 11 elements because it starts counting at 0. So this split index naturally will start at 0 as well. And then it will update when I draw stuff. I am assuming that we are going to be calling this 60 times a second or 30 times a second. So I assume that this is going to be called often, and that's where I'm going to update the split index. Oh, so I need two things actually. I need to know where I am because I will be updating this. So it's going to start, this split index is going to start over here on the left, and then I will need to update it. So I will need to push it forward in time. That means that I need to store it, but I will also store something else, which is last time precise, or last time. Why do I need that? Because when I am called again, I will need to know how much to advance by. And that is based on the current time precise as well as on the last one. I need to know how much time has elapsed to know how much forward to push the split index. So now the data structure has 12 elements. This 11th element is the last time. And how does it start? Well, it's kind of complicated. I could start it at time precise, but that's the date of the creation of the data structure. So I think that instead I'll start this as undefined. And then we'll have to handle the case of undefined last time over here in draw. Yeah. Okay, so far so good. I don't think I broke anything in the process. Let's see if everything is still drawing as it was. Because I added new fields to the data structure and everything's still drawing just the same. Great. So now, of course, I will do this split and I will blit twice to make the thing look like it's scrolling. But for now, I won't do it. I will keep things simple. I'll just draw. I'll draw the place where the split is happening. And then the split should be following this line here that I'm following with the cursor. So let's go to the bottom of the function where after I have splitted everything, and I will gfx rect at what is the x position? The x position is maybe at this split point is with respect to the off-screen canvas we are drawing to. So maybe I will draw there. No, because if I do that, then I will have to erase it later. So I will do a quick thing here where right now I am drawing this waveform at space 2. I'll draw this at space 0. And remove and re-add just to make sure that it is still working just the same. And I will wait for it to wrap around. It's wrapping around fine. Okay, so now I can treat the origin of the off-screen canvas the same as the origin of where I'm drawing to. Of course, later I will have to make things a bit smarter in that aspect, but for now it will do. And Arya is asking, will there be a waveform zoom function? That is, are we generating 60 frames of drawings, or do you have to draw all samples and refresh the drawing every 60 I guess frames, if that makes sense. Okay, so will there be like a waveform zoom function? Sort of. The way you can do this is you can just make a very large off-screen canvas that we are updating to, and then when blitting it, you can zoom into the thing by blitting certain parts of it. So that's something you can do. Now, this data structure, this waveform display, is not your guy if you're interested in doing something like an oscilloscope, because in the oscilloscope, like this one, if you're zoomed all the way out, it kind of looks like a waveform display. And on this one, you can, I think, very clearly see, maybe not on the stream, but I can clearly see it kind of jumping around. So I haven't really looked at the source code for this, but I'm pretty sure that it's relying on the timing of these functions to do the scrolling. But the point here is, this waveform display actually is storing every sample. So if you want to zoom in, I will hold so it's not moving as I zoom in. But if you want to zoom in, you can get down to the individual sample. And that's not this guy. Okay, so this guy is going to be optimized. It's going to use less memory. It is going to be optimized for this kind of drawing, not getting down to the individual sample. Of course, if you wanted, you could have sort of the best of both worlds using the approach that REAPER uses when drawing waveforms over here. We discussed this already. It's just to use my component up to some point and then do the thing that they do here. So that's a possibility. But still, you will be able to zoom in. You will be able to do something like this. You will be able to do something like that. You just won't be able to do something so narrow like this. I am not optimizing this data structure for that because the inspiration, the reason why I want it is to do something like the era de-esser and to do something like the FabFilter Pro C2, to do something like the Melda compressor that we looked at briefly. So those are my inspirations. I don't want necessarily to have something that kind of looks like this. But I, of course, will want to build, or not to build because I have already built one, but I will want to revisit my oscilloscope at some point using the library and maybe improve on it, because I think that there are some things that this oscilloscope does, the one that comes with REAPER, some things that it does that are great, but there are some things that it does that are not so awesome, and I think it can be improved. So we'll get to that. We'll get to that. And Glass Audio is here. Hello, great to have you here. Sorry to go off topic, but if I wanted to make a VST3 plugin, what language would I use? You would use C++, and you should join our Discord because there we have a group where we are studying C++ and how to do VST3 plugins. And we are meeting every 2 weeks. We have a group of people that are doing all sorts of interesting things. And C++ is the language to do that. Now, if you look around, there are other languages capable of producing VST3s. Some of them may be even easier to learn, but they are definitely not the standard that everyone uses. Everyone uses C++. So go to the Discord. I can put a link to the Discord for you to follow. And then join our C++ study group. Just give me a moment to grab that link for you. Here it is. And then when you join that group on Discord, go to a channel with my name, Leandro Facchinetti, and introduce yourself there. All right, so getting back to this split point situation, let's commit what I have. I just introduced some fields on the data structure, and I made, oh, I don't need this. I made the drawing kind of cheating my way into the coordinate system. It will do for now. So then right after I blit, I will GFX rect. What is my X position? It is this split index. So let me grab those guys, and about here I will have them. And I already know that I will be updating these guys in the end. So I'll just grab them, put them there, and reverse. Just like that. All right, so what's my X position? It is my split index. What is my Y position? It is 0. What is my width? I will do a width of 10. Oh, what's my color? I will do this in white. Or maybe not white, I will do this in red. And what is my height? It will be the height of the image. Oh, is this right? Doesn't look like this is right. Let's go over this again. Image, scaling, rotation, X, Y, width and height. Shouldn't it be width and height? It should be width and height. And then X, Y, width and height. Okay, that sounds about right. We probably fixed the bug over here. All right, so this should be drawing red a rectangle at the split point. Right now, we are not moving the split point anywhere, so I expect the split point to be just at the left. I expect to see a red rectangle here on the left. And I do. Here is the red rectangle. Now, let's commit what we have and do something silly. Let me just review what I have. Split index and split index last time. Split index and split index last time. And all of that drawing situation. Great. So now let's do the silly thing, which is to just put the index, the split index, right on the right head. So what I will do is, before I draw anything, I'll just take the split index and say that it's equal to the right index. What's the point of doing this? I just want to see it moving around. I just want to see it circling around. Okay, it is circling around. And the reason why I wanted to do this is because I wanted to see it if it was jumping around. Because when we just had that scene on the drawing, it was kind of hard to see if it was jumping around. It didn't look like it was jumping around, but now that I have a red rectangle, I don't know if you see that, but I definitely see it jumping around pretty much in the same way that the other waveform displays kind of jump around in the way that I don't like. And I think that it all has to do with the timing situation that we are about to fix. So let's look into that. Well, first of all, I want to deal with the case of an uninitialized last time. Okay, so I want to check what is my last time. Is it equal to undefined? If so, then my last time is equal to my time. Hang on, can I have a variable called time? There is a fair chance that I cannot. Yeah, time is a function, so let's not have that as a variable name, because who knows what may happen. So I'll not have that as time, I'll have that as maybe that. And then did I remember to add this to the local variables? I think I forgot. So we'll need these two guys right after the right index, which is here. And then way below, we'll have time. hang on, we had that here. That doesn't seem right. I'm trying to have these variables in the same order that they appear in the body. Maybe not a great idea, but that's what I'm going for. Right, so what is this time that I keep referring to? Well, it is just time precise. And why do I do things in this order? Well, because this is just me getting a hold of the current time. If the last time is undefined, I want it to be exactly the same as the current time. So that's why I assigned it to a variable here, because I want the difference between the two to be 0. The difference between the time and the last time I want to be exactly 0, because I don't want the split point to advance at all. So now I will have a variable called elapsed time, which is just the difference. It is the current time minus the last time. And this is guaranteed to be a positive value because time moves forward, so this number is guaranteed to be bigger or equal to this one. In case the thing was undefined, it will be exactly the same, and this elapsed time will be exactly 0. And that's what I want. Now, of course, I will also need to remember to update my last time at the end. When all is said and done, I need my last time to be equal to my time. So this is going to be the last line on this algorithm. Now, we'll need to see, we already know how much time has elapsed since we last ran, but we need to make the update to the split index based on that. So how much is this going to move forward the split index? Well, we know that the split index has to move from 0 to the width of the image, which is this. So the split index has to move up to there. So maybe let's draw some points of reference here. This is point of reference 0. This on the right is the image width. And that's the distance I want to travel overall. And I want to travel this distance. I want to go from 0 to image width in this duration. I want to take this long. I do have a variable called image duration. So I want to go from here to image width, and I want that operation to take this long. So I guess what I want is to take the width divided by the duration multiplied by the elapsed time. That should give me how much the split point has moved ahead. Let's see if I get the right idea. Why do I have this here? I think it was me starting to think about this, right? Right, so I want to plus equals that. Oh, actually, I want this to wrap around in the end, so I will use my circular counter. Yeah, that's the version I need to use. So this is, what is my circular counter? It's my split index itself. What's the minimum? It's 0. What's the maximum? It's the image width. When I get there, I want to wrap back. And what is my step? This. I think I will put some new lines in the hopes that it makes it easier to read. Can I pre-compute this? No. Well, I could pre-compute that, but is it worth it? Probably not. It's just saving one division, because this much is changing every time, so I cannot pre-compute this step. But I could pre-compute the width divided by the duration. I don't think it's worth it, so let's give this a test. Let's see what this looks like. Okay, it's still just pinned to the left. So there's probably a bug of a variable that I named wrong. Well, the time elapsed I haven't declared as a local variable. It's leaking here, as you can see. But the good news is that it is updating like it should. That's good. Now I can just declare it as a variable right after maybe this one, I guess, because I compute the time and then the elapsed time. And I'll do a full compile reset in the hopes that that helps anything. It doesn't. So we are about to start debugging and hoping for the best. So I will commit what I have. And then we will start adding debug statements. So of course, the most important thing, the one that I want to look at, is this index. I suppose it's going to be just 0. No, it's actually not. It is incrementing. But it's incrementing by a very small number. Oh, I think I know the problem. The problem has to do with the units of measurement, because the duration here is given in samples. But for this scrolling, I need the duration in seconds. Now, I could just multiply back or use one of the conversion functions, but I think it makes more sense for me to store these two in the data structure and pull them out independently. So let's change the definition of the data structure, because I will need the duration in samples when I'm computing, for instance, this. But I will need the duration in seconds when I'm computing the other thing. And I guess I will do the duration in milliseconds, just because milliseconds are more useful as elsewhere. So I'll take the duration in milliseconds and the duration in samples. All right, so let's add a field. This is going to be the duration in milliseconds. Did I spell this right? It seems like I did. And this is the duration in samples. Now, naturally, this is going to all change. So let me grab the equal sign and do a cool little trick. Okay, so now I have a new field. And let's look for duration. This duration used to be given in samples, so I'll have to change the way that it's used here. Now it will be given in milliseconds. And this is the duration in milliseconds. So duration in milliseconds and samples. And then I will use my milliseconds to samples unit converter. Just like that. And then I will have to chase every occurrence of duration because they are all going to change. Luckily, there seems to be only one place. And this is in samples. And I will make another one in milliseconds. And then over here, where I am doing this in samples, I should be doing this in milliseconds. Oh, and this elapsed time is given in terms of time precise, which in turn is given in seconds. So I want to turn this from seconds into milliseconds. No, I have to multiply, right? 1 second has 1,000 milliseconds, so I have to multiply just like that. Okay, let's give this a try. And now it's moving along. And it is jumping around less, I want to say. It does look smoother. It doesn't look as smooth as I would like it to be, but it does look smoother than what we had before, I think. And there is one fine advantage of doing this. Maybe not an advantage, but there is a fine property of this, which is it is following the right head well enough, even though they are completely unrelated. The red rectangle is based on the current time. The right head is based on the timing of the UI thread. So they're in completely different schedules, and yet they are following each other as they should. Awesome. This is good news. All right, so let's see what we have changed. All right, everything in here seems to be correct. So now let's try to do the trick to wrap all of this up and actually scroll things around. So now I will not draw a rectangle on that split. Instead, I will blit things differently. So I will do the blitting below. And I will blit this image twice using different coordinates. So the first time around, I will want to blit the thing to the left of the rectangle. So I will want to blit the image, scale and rotation doesn't change. The X position is going to change. The X position is now going to be the split index itself. No, I want to blit everything to the left of the red. So the X position is 0. The Y position is 0. The width is the index. The height is the image height. And then in terms of the destination X and Y positions, I want it to be X plus No, I want it to be the width minus the split index. And this way it's going to be bleeding here on the right of the image. And then the Y oh, I guess I have to have X plus width minus split index. The Y stays the same. And width and height, I want to change the width. Now it needs to be this. And I will remove the second bleed for now. Let's see what this looks like. Okay. It is not quite working. Let's review this. This is... Let me review the fields as well, because I may have them mixed up in my head. Not the fields, the arguments. So the arguments are the source, the scale, rotation, source X and source Y, source width and source height. Destination X. The destination X I want to be the X position of the component itself plus the width of the component minus the split index. That seems right. The destination Y I just want it to be Y. The destination width, I don't want to change the scale of anything, so it needs to be the same as that. And then the destination height should be just the height of the component. All of that checks out. Huh. That is, oh, interesting. It seems to be distorting the middle here, so this distortion seems to have to do with the width of stuff. Yikes. I don't know. Instead of trying to figure this out, I will try to do the other one. Maybe that will help. So I'll now try to bleed everything that was to the right of the rectangle. So it's the same image, the same scale, same rotation, but this time the X position of the source needs to be the split index. The Y position of the source is 0. The width is the width of the image minus the split index. This is getting too long. I will put some new lines here and there. Okay. And maybe I will group widths and heights like this. And X and Y's, the corresponding X, Y's, widths and heights. Does that help readability? I think it may. All right, so the second one is the split index 0. And then what is the width? It's the width of the image minus the split index. What is the height? It's just the height of the image. What is the X? Well, I want it to be at X, so that's all right. And Y is Y. Then what is the width of this destination? It should be that. And height, just like that. Okay, let's see what this looks like. It's probably gonna be crazy. Okay, it is kind of looking the same. I sort of want to put the effect on the track again. Oh, no, it's not the same. It's scrolling. It's scrolling very weirdly, so I do have the coordinates wrong. But the idea seems to be right. Oh, and look at that, my buffer size is wrong. My libs have been out of sync with my audio this whole time. Take that. Is this better? I hope that this syncs better. All right, so there is something to be said about this whole scaling thing. It is kind of wacky, but the two pieces seem to be gluing right here in the middle, and that's good news. All right, let's go over what we changed. We moved this split to the bottom because we want to have the new split index. And then we computed the coordinates, which seem to be wrong. The coordinates don't seem to be right, but yeah, we just have to work out these formulas because we have already proved that the split index is in the right location. How can we do this? Well, let's just get some red rectangles over the screen, trying to figure out where they should land. So I'll do gfx rect at the split index to begin with. Oh, and I will want to do all of this after the bleeding because I want to see on top of the bleeding. So I'll do it here. And then what is my x position? It's the split index. What is my y position? It's 0. What is my width? 10. And what is my height? The height of the window, or the height of the component. Okay, so it's moving from left to right in a way that makes sense to me. Okay. What's next? What do I want to check next? Well, I am trying to bleed everything to the left of the red rectangle. So I want to start at x0 and go up to split index. That much makes sense, and this also makes sense. So I'm betting that the issue is here. What is this? Let's plot that. That looks correct to me. Because this is the place hang on. I have image height and height as the last lines. This cannot be right. I guess this should be image width. Yeah, I think I found my error. Some good old copy and paste. Let's go over this again in detail. X and Y 0. Then split index image height. Then what is the X position? It's the X position of the component itself plus the width of the component minus the split index. The Y position of the component. And this doesn't seem right. This should be the same as that. And then the image height. Yeah, these coordinates are not taking in account everything that they need. I can tell. But we'll have to revisit this because this is not taking in account the X position of the component itself in several places, and the position of the component is now 0, so adding 0 doesn't make any difference, but it will be wrong as we translate this component around. But we'll get to there when we need. Okay, all right, there you go. That was the issue. Now, this is scrolling, as I promised. It is kind of jumping around as the other plugins do. I wonder if there is anything that can be done about this, because we are doing this based on the timing. We are doing this as correctly as I can make it. So this jumping around, I guess, is just maybe REAPER not being able to refresh the window as often. I don't know. Let's commit what we have because we fixed the bug. And let's change this frame rate to be like 15. So we are making things easy on the plugin. And then it's very jumpy, but at least it's consistently jumpy. Let's try 30, which is the default. And at 30, it jumps around ever so slightly, but less than at 60. I guess this is the best we can do. And I'm sort of seeing something weird. It may be an optical illusion, but it seems like the waveform is like expanding and contracting. Do you see that? Very weird. But there is something else. That is something else that is much more noticeable. And I think that if I decrease the frame rate, it will be even more noticeable. It is this glitch here on the left. The reason for that is that our split point, it shouldn't be like one location. It should be like an area. And there is this concurrency problem occurring, right? Between writing to the image and drawing the bleeding the image. And this concurrency problem means that we need some buffer to work with. And this is similar in spirit to how there is this buffer here. Like this is some amount of give because of the timing of the two things. So we'll need something similar to that so that we can get rid of this much. So in effect, we will not be splitting right at the split point. We'll be ignoring some samples from before that and some samples from after that. Or maybe just some samples from before that. I'm not really sure, but one of the two. We need to ignore some samples in the split point. And at 60 frames, this is much smaller because the UI thread is running more often, so it has more opportunities to update this on the left. But yeah, let's bring this into the formula. So when we are using the split index, we need to take this in account, this margin, or maybe the split width. I think that's what it will be. So I'll have a local variable here for the split width. And I will hard code this for now, but maybe we'll need to think about a formula for this. And I'll do it right here. And right now it will be like, I don't know, 20 columns. And this means that we'll not be necessarily plotting 5 seconds, we'll be plotting ever so slightly less than that. And maybe we would need to even take this in account. But I'll cross that bridge when I get to it. I'll think about this later. So let's think about this split width and how it relates to the coordinates that we are computing. Well, I guess I will split this difference in half. Yeah, I'll split this difference in half. So from the split point, I will ignore 10 columns to the left, 10 columns to the right, which means that when I'm bleeding the image to the left of the split point, which is this split, I'm bleeding to the left of the split point, I need to make the width of the bleed smaller. And this is the width of the split. Just made it smaller. Oh, but I don't... Do I want to change the x coordinate? I don't think so. I'll just stretch things a little bit. Yeah. And then over here, when I am bleeding things to the right, I will also want to remove this from the width. So I will subtract this here, but I will also want to add this here. Because I am at the split index, I want to jump one width worth of columns to the right. Let's see what this looks like. Okay, so we have to wait for this to get to the left, and then we'll see if it's glitching. Oh, it is doing something weird. It has like this weird jump in the middle. Yeah, this computation is wrong. But you know what? I'll just revert this. And now it looks like this. Is it glitching on the left? Yeah, sure, it is glitching on the left, but for the most part, it looks very nice. And this happened before on the stream, so it's not the first time. Yeah, we have to think a bit more about how we are bleeding stuff, and all of these formulas have to be revisited because I want to be able to translate this component. I want to be able to draw it on the screen, whatever I want. There is also some transparency issues because right now I'm using pure black and pure white. So if this is on top of anything, it will be redrawing on top of the thing. I will want to use some transparency. I want to assign colors to this. So there is a lot more to this component. There is a lot more to this component. This is a big, interesting, complicated component that has to do with like timing issues and everything. But we are getting there. This is scrolling across the screen smoothly. Let's compare this to our references. The era de-esser. Let's put that here. And also the M compressor in this mode. And this is to some extent not a fair comparison because I am doing this in JS Effects. The performance guarantees are very different in JS Effects to what they are in C++. And for whatever reason, when I dropped these effects on the track, the seam here, the glitch became bigger. If I bypass the thing, is this helping? No. Does it have to do with the size of the screen? No. But the glitch is much bigger now. And we don't have the notion of scaling yet. Go figure. All right, so ignore the problem here on the left. Let's just look at the waveforms and see how they are scrolling smoothly or not. Let me bring the M compressor as well. And let's try to get this on the screen at the same time. So I would say that apart from, of course, the glitch, I think that the Melda one is the smoothest, and then ours. And I think that Acusonus era deesser is probably the worst in terms of jumping around. Ours isn't perfect, but it's okay. Given that we are in JSFX and everything and all the shenanigans we're pulling, I think that this is okay. Yeah. All right. I think this is it. So the plan is that tomorrow I will be over at IDQD Sound. We will be working on some of my songs and talking about ambisonics and other fun stuff. Then I think that on Tuesday, I will be back to this. I think that's the plan. On Tuesday, I will be back to this. I will fix this glitch. I will do the transparency thing I mentioned, maybe the scaling thing that we talked about, coloring, still lots of stuff to do. Oh, and rectification, the contours. They don't have contours over here, but I think that we want contours just like the ones over here. So we'll have to work on that as well. One thing is that our waveform is definitely bigger than this one, so maybe they have such a smooth waveform because it is smaller. This one is bigger, even bigger than ours, and it's glitching more, so maybe that explains stuff. I don't know, can I zoom in way more? Oh, I'm zooming in the wrong axis. All right, whatever, it is what it is. Yeah, so on Tuesday we'll continue this. Make sure that you go to IDQD Sound tomorrow for our audio production stream. And I see you tomorrow. Yeah. Thanks for being here. Thanks for chatting with me and for joining me on this ride. I hope you are enjoying this. Have a good one.